Look up to the sky. What's the first thing that you see? It's our brilliant sun shining down on us. Ever wondered how the sun emits heat and light? It all begins with nuclear fusion at its core, where immense pressure and temperatures exceeding 15 million degrees Celsius cause hydrogen atoms to collide and fuse to form helium, releasing an immense amount of energy in the form of heat and light. This fusion process is incredibly efficient and has kept our sun shining for about 4.6 billion years. The sun's journey began in a stellar nursery, where a cloud of gas and dust collapsed under gravity, forming a protostar. Over millions of years, the core's temperature rose, igniting nuclear fusion and birthing our sun. Since then, the sun has been a stable energy source, but it's not without its dramatic moments. Solar storms, caused by bursts of solar wind and magnetic fields, can disrupt satellites, communications, and even power grids on Earth. These storms arise from sunspots, which are cooler, darker areas on the sun's surface that indicate intense magnetic activity. Sunspots follow an 11-year cycle, peaking in periods known as solar maximums. During these times, solar activity is heightened, leading to more frequent and intense solar storms. Imagine if the sun suddenly stopped emitting heat and light. Our planet would plunge into darkness and freezing temperatures within days, making life unsustainable. Photosynthesis would cease, collapsing our food chain, and temperatures would drop drastically, freezing the planet's surface. Luckily, scientists predict the sun still has about 5 billion years left before it exhausts its hydrogen fuel and transforms into a red giant. When that happens, the sun will expand, engulfing the inner planets, including Earth, if it still exists by then. After shedding its outer layers, the remaining core will cool and shrink into a white dwarf, slowly fading over billions of years. The sun's gravity is what keeps the planets in orbit, pulling them toward it, while their inertia keeps them moving in a circular path. This delicate balance is why planets don't spiral into the sun or drift away into space. The sun's immense mass, making up about 99.86% of the total mass of our solar system, creates a gravitational pull that keeps everything from Mercury to Neptune in check. Interestingly, the sun's composition is predominantly hydrogen, about 74%, and helium, about 24%, with heavier elements making up the remaining 2%. This composition explains its strong gravitational pull and its ability to sustain nuclear fusion. The energy from the sun travels through space as electromagnetic radiation and reaches Earth in about 8 minutes, a journey known as the speed of light. This energy influences everything from our weather to plant photosynthesis, driving the water cycle and supporting life on Earth. Solar flares, which are sudden flashes of brightness caused by magnetic energy release, can affect radio waves and pose risks to astronauts by exposing them to increased radiation. These flares often occur near sunspots and are more frequent during solar maximums. One of the most intriguing aspects of the sun is its outermost layer, the corona, which is hotter than its surface, a mystery that still puzzles scientists. The corona reaches temperatures of up to several million degrees Celsius compared to the surface's relatively cooler 5,500 degrees Celsius. The corona extends millions of kilometers into space and is visible during a solar eclipse as a glowing halo around the sun. The sun also plays a crucial role in shaping the heliosphere, a bubble-like region of space dominated by the solar wind that protects our solar system from cosmic radiation. The solar wind, a stream of charged particles emitted by the sun, interacts with planetary magnetospheres, influencing space weather and creating auroras at the poles. As we continue exploring, we learn that the sun's energy output, known as solar luminosity, drives our climate and supports the food chain. Solar energy technologies, like solar panels, harness this power to provide renewable energy on Earth. These panels convert sunlight directly into electricity through the photovoltaic effect, offering a clean and sustainable energy source. And speaking of life cycles, the sun is currently in its stable phase called the main sequence, where it has remained for most of its life. This phase ensures a steady energy output, allowing life to thrive on Earth. In about 5 billion years, the sun will enter its red giant phase, expanding and shedding its outer layers. This transformation will dramatically alter the solar system, potentially swallowing the inner planets. After this phase, the remaining core will become a white dwarf, gradually cooling and dimming over billions of years. Despite these cosmic scales, the sun's influence on our daily lives is profound, from driving the water cycle to enabling solar-powered innovations. The sun is not just a star, it's the cornerstone of life as we know it. Thanks for joining us on this enlightening journey. If you enjoyed this video, don't forget to like, share and subscribe. And remember, keep exploring and stay curious about the wonders of our universe.